Electrons, guys, this is still going to be on the test right here, okay? You cannot forget about electron configuration. Remember, these numbers right here at the beginning mean how many rings are on each level, okay? So if I have an atom that is this, that means it's saying 1, so I'm going to have 1 orbital. It says 2, I'm going to have 2 orbitals, and then these tell me how many electrons go on each, okay? So this would be 1, 2, 3, 4, 5, 6, 7, 8, okay? So how many valence electrons, Ariana, does this have?
8.
8. Awesome. What if I did this, Ariana?
It's still 8.
Is it still 8?
No.
Because valence electrons are the last ring. So how many does it have on the last ring, Ariana? 1. So what family would it be in, Charlie? If it only has 1 valence electron?
The first one.
Yeah. Say the name. All right, I'm going to skip ahead. Alkali metals. There you go. All right. So what happens, though, is this. All right. Is it easier for me to pick up one thing, or excuse me, to drop one thing, or to pick up 8 things?
Drop one thing.
Oh, no,
To drop one thing. So if it's always trying to get to 8 using the octet rule, is it easier for this thing to drop 1 electron and then it'll have 8 on its last shell, or to pick up 7 things?
Drop.
Drop, that's right. So when I drop it, look what happens. All right?
Wow.
So, stop it. All right, next thing on the checklist is oxidation number, okay? Using the octet rule and me dropping is exactly what I'm talking about. So if you do not have this written down, this is your oxidation hill. You need to write it down, okay? It's extremely important. All right, valence electrons are always underneath, okay? And all you do is find how many valence electrons, and then you read the oxidation number. So, Nasir, if I said that I have an element that has 5 valence electrons, what is its oxidation number? What did I? Yeah, because you weren't paying attention. Go ahead, Charlie.
-3.
-3. Look up here. All you do is find the number and go right next to it. So if I tell you, Nasir, that there is a element with 2 valence electrons, what's its oxidation number? Plus 2. Plus 2. Okay? Micah, if I say that I have valence electrons of 4, what's my oxidation number? What? Plus or minus 4. Yeah, exactly. That's right. It's both at the same time. Okay? See how easy this is to use, guys?
Yep.
All right, so here's the hard part, okay? And pay attention. Remember cations and anions. Cations, I'm getting rid of negatives, so I'm becoming more positive in my life. Anions, I'm gaining more negatives, so I'm becoming more negative. So if I look at this and I say, does this element gain 2 electrons or lose 2 electrons, Fernando? Gain 2?
No, lose 2.
Lose 2, that's right. It gets rid of 2 electrons, that's why it's plus 2. So, Catherine Adamic, does this one gain 2 electrons or lose 2 electrons? The one I'm pointing to, -2. It gains 2 electrons, remember? It's opposite. I'm putting more negative into my life, okay? Sammy, what about this one? Is this gaining 2 electrons or losing 2 electrons? Or 3? 3. What? Gaining 3 electrons. Ladies, question?
No.
Then don't talk. All right, good? All right. This Cook, super helpful hint for the test. You are going to have 3 things you need to know how to graph, okay? And they're listed right here in this box. If you need to write that down, you can, but I'm going to go over all 3. The first one is atomic radius, okay? Atomic radius is how fat or how big an atom is. It is the distance between the nucleus and the furthermost electron, okay? So that guy right there. All right, you're going to know how, I can't talk. You're going to need to know how to graph this. So here we go. On the periodic table, this is my little periodic table, see it matches. Atomic radius increases as you go this way to the left and increases as you go down. Charlie, I like it. You're already ahead of me. Atomic radius. Okay? What I was trying to say is, Charlie, what is the fattest element on the whole entire periodic table? Francium. All right, I want everybody's eyeballs up here. This is Mr. Cook's dumb little analogy, but it works. I'm a small little atom. I'm on the left-hand side of the periodic table. As I move across, I get fatter or bigger.
Oh, let me get it.
All right? So if I'm on this side of the table, and I'm here, and I start moving this way, what's going to happen? My atomic radius is going to get smaller. All right, cool. There we go. Check that. All right, ionic radius, okay? All you're going to have to know for the test, guys, is if I have an atom like this, Catherine Adame, and it starts off big and then goes small, what happened to it, Catherine? What's the difference between this one and this one? Because it's the same element, but something changed.
Who get this fixed?
All right, Micah was really excited first. Go. It is a cation, but what does that mean? It dropped a what? An electron. You guys are freaking geniuses.
I want the exist.
Right. Cation, anion. So guys, if you have an atom that's bigger and then gets smaller, it means it lost something. It lost an electron. So what's the opposite of that, Catherine? You got this one now. It gained one, so that would be an anion. Guys, that's it. That's it for ionic radius. Ionic radius. Good job.
I'm finna get a honey.
Ionization energy, okay, is the next thing you're going to have to graph, and the next thing on our review, all right? It's something you're going to have to know how to graph on the periodic table. Ionization energy, if you forgot, is the amount of energy it takes to lose an electron, all right? And the way it works is it's pretty much the opposite of atomic radius. As we move across the periodic table this way, it gets stronger. As we go up, it gets stronger. So the arrows should kind of look like this. So Charlie, since you were my guy who did it last time.
Fluorine.
What?
Fluorine.
Our fluorine, okay, is the strongest ionization energy that we have. Why is that? Because the noble gases, guys, don't do anything. They're not reacting.
Use the king.
So that's right, you can't use the king, so ignore them. So the strongest ionization energy is fluorine. All right? So here's how this works. I'm an element on this side of the periodic table. I'm small and I'm weak and I can't lift anything. I don't work out, right? It's a dumb example, but it works. As I move this way, I get stronger. Okay?
So it's the opposite from the
That's right. It's the opposite. See the arrows? Okay? So, if you guys can remember that, you're going to be good. Okay?
You leave these up tomorrow?
No, I cannot leave these up. NRG, energy. All right, so, next one. Very good. All right, electronegativity. All right, is the last thing we got to talk about. It's also what? The last thing you're going to have to graph on your test. Okay? And guess what? It's pretty simple. It's the energy required for something to gain an electron or steal one. Okay? It's how great something can steal or gain an electron. All right, and guess what? God or Allah or Buddha or whatever you believe in, I personally believe in God, Jesus, but,
Buddha.
Whatever you believe in,
Buddha.
was nice. Whoever invented this magical world of ours was nice because guess what? It's the